Okay, I think we'll get started. Good evening, everyone. Thanks for joining. This is a joint IEMA and Energy Institute event, so thank you for everyone who's taken the time to join us. My name is Chris Wilson. I'm the chair of the Northwest Committee and also a member of the IEMA committee as well. I'm joined by Dan Hubbard, who is the secretary of the Northwest Energy Institute. I'm going to pass over very shortly to our guest speaker, Adam Baddeley from Progressive Energy. Just before I do that, a little bit of housekeeping, just to remind everyone that the call is recorded. It will be available within a couple of days on the Energy Institute's YouTube channel. All those that have registered will get a link to that, and then you're free to share from there on. Please do ask questions as they come up in the comments. We'll try and organise those, and there's a presentation of about 30 minutes, and then we'll use up whatever remaining time there is for questions. I think it was initially advertised for 1 hour. I think the invite might have said 1 hour and a half. So we'll probably keep to as closer to the hour as possible, if that's okay. Clearly depends on the questions and the interest. I see everyone's muted, which is good. So yeah, probably best just to keep on mute and videos off to try and save on the bandwidth. Just a few future things. Please keep an eye out for future events in the Northwest. We have various themes between IEMA and the Energy Institute. A lot of them, of course, crossing over between net zero presentations, low carbon tech, etc. So we do have an event coming up at the end of June, which will be advertised very soon, which will be a site visit to a solar PV demonstration to a brewery just south of Lancaster, in between Lancaster and Preston, as well as a talk from Northwest Electricity on how they're supporting load growth with things like heat pumps coming on board and EV charging, etc. If anyone's on that is involved in an interesting project or an interesting site that could host a site visit, we're always keen to go to new places, find out about new projects. So please get in touch with the contact information on the screen. And similarly, if anyone wants to make a longer-term commitment or contribution to either of the organisations, then please get in touch. We take new committee members at any point throughout the year, and if you want to get involved in organising events or lead in the direction of the group, then please get in touch. So moving on to today's presentation, it's from Adam Baddeley from Progressive Energy. So he's going to do, he's kindly agreed to do a presentation on HyNet, which is the fuel switching demonstration project. As we know, hydrogen is possibly going to become quite a significant part of the UK's energy consumption going forward. I think predicted to be up to 35% by 2050, coming from a very low base as of today. So it's one of those things we need to understand in terms of our transition to net zero and all the associated considerations around cost and safety and green credentials as well. So Adam's been involved in HyNet since its inception in 2016, and he's got over 20 years of consulting experience for both the government and the private sector. So I'll pass over to Adam now, and we'll pick up the questions after his presentation.
Excellent, thanks Chris, and thanks all for coming along this evening. I'm just going to share my screen and put the slides up. Just bear with me a second, and I guess I'm hoping. Oops, that's gone on. I'm hoping that's gone on to slideshow. Please shout, Chris, if it hasn't.
Yes, perfect.
Fantastic. So yeah, hi, I'm Adam Baddeley from Progressive Energy. I'm head of industrial hydrogen. Progressive Energy is very briefly. We are a project developer in the clean energy space. So our raison d'etre is to develop and deploy energy infrastructure projects and to take an equity stake in those. As Chris said, I've been involved in HyNet since inception in 2016. I'm going to talk to you today. I'm going to give a sort of overview of the HyNet project and a sort of update on the current state of development, but also focus on the different uses of hydrogen, particularly used by industry, and delve into some of the demonstration projects that I've been running, in particular, whereby we've been putting hydrogen into a live manufacturing environment at major sites in the northwest. So just to sort of set the context, I mean, HyNet is what we call an integrated hydrogen and carbon capture and storage project. It focuses on what is previously known as blue hydrogen, often now known as CCS enabled hydrogen. I'll talk more about sort of blue-green in a second. It's based around the northwest and Wales, and hence hopefully got people both from the northwest and Wales on, and North Wales on. It started off in 2016 as an innovation project, funded originally by Cadent, the operator of the existing natural gas network in the northwest. It's now become, over the last 6 years, a fully fledged infrastructure development project, so with about 100 million development budget. So that 100 million going into the consenting processes for the different elements of the infrastructure and into the detailed or front-end engineering processes associated with that infrastructure. The reason why we chose the northwest, going back 6 years, was sort of between the northwest and Humber at the time. The reason why we chose the northwest was because of the proximity and availability now of opportunities to store carbon dioxide offshore in the depleted oil and gas fields in Liverpool Bay, but also the natural assets, the infrastructure that we can develop for hydrogen storage in what's known as the Cheshire Salt Basin near Northwich, where natural gas is stored today in multiple caverns. We intend to store hydrogen in a very similar way, underground in salt caverns. It's an approach that's used elsewhere in the UK already, on Teesside and in other countries around the world. So the focus or the sort of centre of HyNet is around hydrogen production at Stanlow Manufacturing Complex, which is operated currently by Essar. So production of blue hydrogen essentially involves, in very simple terms, putting natural gas into the plant, the production plant. Out of one pipe comes hydrogen, out of the other pipe comes CO2. Without the CO2 sort of capture, transport and storage element, we wouldn't be producing low carbon hydrogen, and the focus of the project is to produce low carbon hydrogen and distribute that via a new hydrogen network. I don't know if people can see my cursor on the screen, but the network's going to be deployed in several phases. There's an initial phase which is very close to Stanlow, that'll be supplying hydrogen to 2 or 3 industry sites, and potentially the hydrogen village project that's being developed nearby. And the first sort of major phase of deployment or significant lengths of pipeline, about 110 kilometres of pipe, the sort of solid blue line that you can see on the screen there. Then going into sort of phase 3 of the pipeline, that extending sort of at all ends of the phase 2, going up for about a further sort of 230 kilometres of pipeline. I talked about the CO2 capture. What we're able to do with this project, we've always been focused on cost and deliverability, is to reuse a lot of the CO2 transport and storage infrastructure. So natural gas currently comes onshore from Liverpool Bay through Point of Air gas processing terminal to Connors Quay power station, which some of you will be familiar with in North Wales. So we will be reusing that stretch of pipeline. So where it once brought natural gas onshore, we will take CO2 offshore into those gas fields where gas has been stored for several millions of years, fully in good integrity, obviously, therefore, in those stores. We'll be putting CO2 into those reservoirs and storing that in perpetuity. So the focus of HyNet in terms of hydrogen use has always been on industry. and largely because of the relatively flat load that industry has, operating 24/7, and therefore, although we will be having a significant amount of hydrogen storage, it minimises the amount of storage that's required to support the network. There's quite a lot less, because of the way the molecules sit together, there's quite a lot less what's called line pack within the pipelines for storage, for hydrogen than there is for natural gas. So that's a new hydrogen pipeline network, rather than, you may have heard of projects that are actually seeking to convert the existing gas network sometime in the future to hydrogen. It's a new pipeline network that will ultimately, if a decision is made to switch the existing network to hydrogen, that will supply into the existing network. But another element of HyNet is to supply a blend of hydrogen into the existing network. So rather than convert it fully to 100% hydrogen, in the initial years, we aim to put a blend of up to 20% by volume of hydrogen to blend that into the natural gas. 20% to about 7% by energy. So you might think that's not significant, but it is a material amount of decarbonisation, and that is at a level that causes no disruption to businesses or households. It's a level where people don't need to change existing boilers, fires, cookers, etc. So it's a non-disruptive technology with material decarbonisation. We also plan to supply the flexible power sector for when the wind's not blowing, the sun's not shining. Hydrogen can be fired in gas turbine or gas engine plant to produce power and fill in those gaps. So quite an important technology in that respect to replace natural gas, and also potentially to the transport sector. I think that's fairly dependent on getting that hydrogen network in place. So it enables a network of hydrogen refueling stations to be deployed, and therefore to sort of stimulate that market, whereby at the moment you've got a lot of fleet operators that aren't really willing to invest in hydrogen vehicles, and a lot of manufacturers that aren't willing to invest in the vehicles till they get the demand from the fleet operators. So I'll talk about demand in a second. There's also another element of HyNet, which is direct capture of CO2 from industry. So that CO2 ultimately will be sort of mixed with the CO2 from hydrogen production in that same CO2 pipeline and transported offshore. It is a blue hydrogen project, or CCS enabled hydrogen project. I also lead our green hydrogen development business unit, as it were. So we're seeking to deploy green hydrogen alongside blue at a lesser scale, I should say. Our first train of blue hydrogen production will be about 350 megawatt thermal. Second train will be 650, taking us to a gigawatt of hydrogen production by 2030. First green hydrogen project we're seeking to deploy by end of 2025. It's about 20 megawatts linked to a wind farm, so power supply from the wind farm behind the meter. Additional power supply from via remote power purchase, a virtual power purchase agreement with a renewable supplier to give us a flat load on the electrolyzer. So I should also say that this main part of the infrastructure in terms of timing, the first sort of phase one, the network and production close to Stanlow, we intend to deploy by the end of 2025. Phase 2 hydrogen network end of 2027, and phase 3 by 2030. So it's a lot of work going on, a lot of engineering studies, etc., and consenting, which I'll talk about in a second. Just in terms of the sort of blue and green hydrogen issue, I mean, government published the hydrogen strategy back in August last year. It's since come out with a raft of documents just before Easter. One being the sort of what's called the hydrogen business model consultation response, and that business model likely to be, well, it is very similar to what's known as a contract for difference for renewable electricity at the moment. It'll be a contract for difference to support the price of hydrogen compared with the price of natural gas. So it'll enable producers of hydrogen, such as HyNet, to sell hydrogen to customers at a very similar price to natural gas. So it'll basically bridge the gap between those two fuels and provide support to the producer. So there's a lot. There has been sort of some negative press around blue hydrogen. Some sort of studies published which don't necessarily use what we'd call objective assumptions, but I think the critical thing, to take from all of that is that the government, at the same time as working on the business model, has put in place and is formalising a low carbon hydrogen standard. So there's a clear low carbon threshold that all hydrogen projects, blue and green, have to meet to be able to qualify for that business model support. So essentially, if our hydrogen from HyNet is not low carbon, and it's a fairly stringent threshold, if it's not low carbon, we won't develop the project. We won't get the support to build the project. So that ensures and makes our customers, a lot of large manufacturers, comfortable that the hydrogen that they will buy from our project will be genuinely low carbon. So just in terms of how the project's structured, so Progressive, we're actually an SME, so we're about 35 people. Our consortium partners are a lot bigger beasts than us. We tend to be, and we originated the project, and we're still very much involved with the project. We're sort of the glue that holds things together. But we are effectively a group of companies working in consortium, but each responsible for specific areas of the development of the project. So ourselves, in terms of hydrogen production, we have a joint venture company with Essar. We're a minority shareholder, but Essar's the majority shareholder in a company called Vertex Hydrogen that launched a couple of months ago. Vertex will produce the hydrogen at Stanlow and sell that to customers via the distribution network, which will be owned and operated by Cadent, likely in a very similar way that it owns and operates the existing gas network as a regulated asset. CF Fertilisers and Hanson Cement, I was there yesterday in North Wales with Hanson. They are sites from which we will be directly capturing CO2 to go into the CO2 network. CF may also take hydrogen to further decarbonise the process. Essar, I mentioned, was a JV partner in Vertex. There's also direct capture of CO2 from Essar from the catalytic cracker at the refinery. Innovin, a subsidiary of INEOS, is developing and will operate the hydrogen stores at its Northwich and Kuiper project. So we've also got the University of Chester, which is supporting in some of the sort of studies around the work and some of the work around wider skills relating to hydrogen and CCS. But the other thing to mention, you'll see lots of sort of names on the right, is that we've always been with HyNet very focused on demand and creating the market, not wanting to build infrastructure that turns into a white elephant. So personally, I've been working for the last 6 years on developing the relationships with a lot of large manufacturing sites. I think I've got 30 different MOUs in place with different manufacturers in the northwest and North Wales, some of which are shown there. Sort of quite a lot of household names, the likes of sort of Kellogg's and Heinz, Jaguar Land Rover, etc. So we're working very closely with a number of those sites to make sure that they are hydrogen ready. They've done the sufficient technical work and engineering work at the site to make sure they are ready to take hydrogen when it's available from the HyNet project in bulk. And I'll talk about some of those specific sites a bit further on into the slides. So in terms of current status of the project, our partner, I realised I forgot to mention ENI on the last slide. ENI is the Italian oil and gas operator, sort of global oil and gas company. They own and operate the Liverpool Bay oil and gas fields. So they're our partner in terms of CO2 transport and storage. So they will operate the pipelines that move CO2 from Stanlow and from other CO2 capture sites to via the sort of existing, well, via one new stretch of pipeline between Stanlow and Connors Quay, and then via the existing pipeline from Connors Quay through Point of Ayre to initially to the Hamilton gas fields in Liverpool Bay. Eni was awarded its CO2 storage license about 18 months ago, so that work is sort of well underway. And Eni is undertaking the necessary FEED engineering design for the modifications that are needed to that offshore infrastructure, both the top sides and the wells, etc., to enable safe injection of hydrogen into the reservoirs and for long-term storage. In terms of our CO2 pipeline, we are about 15 months, I believe, into what's called the development consent order process. So that's the planning consent process for what's considered nationally significant infrastructure. So if you have a pipeline over a certain length and diameter, you have to go via a DCO. So we are about 15 months into that 18-month sort of information development and application process. We'll be submitting our application to the Planning Inspectorate, I think in about autumn, sometime in autumn this year. That then has a 12-month determination period, assuming there's no sort of legal challenge or to that process. So, you know, we hope to have a determination on that by the end of next year. So, as you can see in that diagram, in that map there, I believe this was part of the last sort of phase of statutory consultation on the pipeline route. So we essentially were consulting on two different routes between Stanlow and to take us to Connors Quay. I believe we've now firmed up which route we're going to take, but we had a good consultation process with a good level of responses from, you know, all different sorts of stakeholders. So that process is well underway, and as I said, we hope to submit our application by in the autumn and get a determination next year. And that process is being led by ourselves in partnership with Eni. So in terms of the hydrogen production plant, again, I was at Stanlow myself yesterday. We had a delegation of BEIS, government officials and Treasury. We were taking around lots of HyNet sites yesterday. Quite a lot of people coming up from Westminster to view the sites which will be producing hydrogen and from which we'll be capturing CO2. So as I mentioned, the production plant is going to be at Stanlow. There's a picture of broadly what it's going to look like there. At the moment, it's just an empty space that's being cleared on the refinery site, ready for us to start works as soon as we get to an investment decision. We don't require a development consent order for the production plant. It's going to be consented under regular sort of local authority town and country planning. We have submitted our application for consent. That process is a shorter one, determined by the local authority within a 3-month period. So we hope to be hearing the outcome of that process relatively shortly. We believe we've got a good chance of consent. It's a relatively small piece of infrastructure relative to the rest of what is on the refinery site, which is helpful to us. We've done our front-end engineering and design of that plant, completed that, which was co-funded by government, to get us to a sort of fully engineered and designed plant and consented plant towards the end of this year that will feed into a sort of wider investment decision on the infrastructure. We're in a separate DCO process, a consenting process for phase 2 of our hydrogen network. Phase 1, which is the sort of 2 or 3, I think 3.5 kilometres of pipeline, which will be, quite close to Stanlow. That will be consented under town and country planning. But this sort of that you can see there, that the sort of map there is for the sort of phase 2, sort of about 120 kilometres of pipeline, Cadent, which will operate the network, is leading that consenting process. As Progressive, we're supporting that. Cadent is Cadent is consulting on the broad, sort of fairly wide route corridors for that pipeline at the moment, and some routing. See, there's a sort of circle there on part of that map, which is, you know, representative of 2 routes down from the main sort of trunk pipeline to take us down to the storage site, which is sort of south and Northwich, to be operated by Innovin. So that's gone through. That process has just gone through its first phase of non-statutory consultation before moving into a statutory phase of consultation later this year, and going through in tandem with the consenting process the front end engineering and design of that pipeline infrastructure. So we're well immersed in that process. I suspect I believe an application for what will be submitted to the planning inspectorate early next year, with the goal of getting a decision on that in early 24 and an investment decision shortly afterwards to enable Cadent to build and start operating that network and supplying the hydrogen from Vertex Hydrogen by the end of 2027. So that's the broad timeline. My slide isn't moving on. Oh, here we go. There we go. So that's, I guess, an update in terms of the sort of major infrastructure design and consenting processes. We've also got a fund. We've got to fund all of this infrastructure. You know, it does need support from government and from energy customers. You know, via consumer bills, which are levied via the network charges, etc. So, you know, it's a hot topic these days with the cost of living, and, you know, the increasing price of energy. It's definitely not straightforward. Ofgem is very active in this process in its role as the energy regulator, but essentially the funding, we've had to go through a lot of competitive processes to be in the frame for funding for major long-term revenue funding, to enable us to upfront fund. You know, all of the infrastructure will be upfront funded by our consortium and essentially paid back over, you know, the support element will be paid back over 15-year period for that infrastructure. We've had to go through a process that government has run, that BEIS, or Department for Business, Energy and Industrial Strategy, that they've run, called cluster sequencing. So the phase 1 of that cluster sequencing process, we had to compete for funding with other sort of CCS and hydrogen clusters. So Teesside, Scotland, the Acorn project, Humberside, I think the South Coast project, a South Wales project. So we were selected, the HyNet project was selected as under what was called track 1 of phase 1 for funding of the CO2 infrastructure. So 2 projects were selected, ourselves and then a joint Teesside Humberside project, with the others being unsuccessful and potentially going into what's called track 2, of which there's little visibility at the moment. So we are ENI, as I mentioned, will be operating that CO2 transport and storage infrastructure. So they are in negotiations with government at the moment over that the levels of support for that infrastructure, as I mentioned, which will be likely to be possibly a sort of regulated asset for the pipeline, in the same way as pipeline networks are regulated today. We're also, government in its wisdom and its desire for competitive process to drive prices down, has run a further competition which they call phase 2 under cluster sequencing, and which has pitched all CO2 capture sites, including our hydrogen production plant, against each other in a competitive process. So not only sort of sites in different clusters competing against each other, but sites within clusters competing against each other towards getting a CO2 capture contract for difference, or in our case, hydrogen production contract for difference. So I think about 10 sites within the northwest have been part of that process. We're awaiting government to announce their shortlist of projects in June, and possibly July, maybe I think June or July, and we will then go into negotiations, or those sites that are selected would go into negotiations with government later this year. So another thing, you know, trying to sort of get that funding in place to sort of in concert with all of the engineering and consenting work. So, you know, all moving in the right direction, but some challenges to negotiate with those processes. I'm conscious of time, so I'm going to crack on. In terms of hydrogen applications, as I mentioned in my first slide, lots of different potential uses of hydrogen. I talked about network decarbonisation and a hydrogen blend, but also potentially in the future, subsequent to a blend, 100% hydrogen. A lot of good work going on the blend via the HyDeploy project that we've been project managing in partnership with Cadent and Northern Gas Networks. We originally ran a demonstration at Keele University in a closed gas network where we supplied a blend, a 20% blend of hydrogen to about 80 residential dwellings and some commercial properties within the university. That was a successful project. We now move forward into a demonstration in Winlayton, which is being led by Northern Gas Networks, which is supplying a blend to about 700 dwellings and a number of commercial properties. That's all going well. No issues with that. We've been able to prove that a blend can be delivered safely into a range of different properties. The next phase of HyDeploy is actually to develop a very extensive safety case, which has already started to enable a change and provide evidence to a change to the gas management safety regulations, which are currently, you can only put about, unless you've got an exemption, you can only put 0.1% of hydrogen into the gas network. We're seeking a change to enable us to put that 20% by volume into the gas network, and then actually deploy that into the network as part of HyNet. So that's what we're seeking to do as part of HyDeploy. The 100% hydrogen picture is again moving quickly. There's been a lot of work through the H21 and the Hy4Heat programs funded by the gas networks and Ofgem and BEIS, really moving forward with what's called the H105 project, where a new set of housing is being switched to or developed on the back of 100% hydrogen being supplied into those properties and commercial properties in Fife. So that's being led by Scottish Gas Networks, and I believe first operation will be early next year. That then is providing the sort of basis for the next phase, which is the Hydrogen Village. Two projects are currently going through front-end engineering and design. One, which is led by Cadent, which is near to Stanlow, which would be ideally supplied by green and blue hydrogen from HyNet, and a second project in Teesside, which is again we're again being pitched in competition, so Northwest versus Teesside, to actually run the first sort of fully 100% hydrogen village. A decision on that will be made as to which village moves forward sometime next in the middle of next year. So a lot going on in the sort of network area. Just to say, in terms of the blend that we intend to deploy as part of HyNet, there are, I think, 7 different network injection points which will enable us to provide a blend of hydrogen to, I think it's about 3.5 million customers on the gas network. And those points that you can see on the map there are all points on the distribution network, which on the what's called the local transmission network, the sort of 35 bar network, where currently is the points which are fed with natural gas from the national transmission system, so operated by National Grid. So we'll inject a blend at those points, and that will filter down into the lower pressure tiers to supply at all pressure tiers into the network. So that all the engineering work for those injection points is progressing at the moment. We've done less work in terms of the transport sector, because we don't see it enabling investment in the key pipeline network. I was involved in a project called HyMotion a year or so ago, and the key part of that was to really demonstrate, and which I think this chart is showing. You've got pounds per kilo of hydrogen produced and delivered along the y-axis, and the different scenarios along the x-axis. What this really, and the OPEX and CAPEX, what this really shows is that pipeline delivery of hydrogen is absolutely essential. I'll talk about it more in a second. I've been running demonstration projects where we're trucking hydrogen around. It's an extremely expensive and non-carbon efficient thing to do. You can only, in what's known as a tube trailer, it looks like a regular HGV with long sort of tubes, pressurized tubes of hydrogen on the back. In an equivalent, truck of petrol or diesel, you can move around about 30 tons of product. In a hydrogen tube trailer, you can move around about 250 kilos of product. So it's not an efficient approach to moving hydrogen around, and pipeline delivery is essential to enable the real decarbonisation of vehicles using hydrogen. We did do some work on potential demand. We believe, facilitated by the first phases of the HyNet network, we can deploy. Apologies to those who are in the transport sector. My metrics are in terawatt hours per annum, which is more of the energy sector thing, which I guess you guys will be familiar with. But we believe about just over a terawatt hour of energy, of hydrogen per annum under our medium scenario could be supplied to fuel cell electric vehicles by 2030. Obviously, a more optimistic scenario, about 2.5 times that under a high scenario. But and that going to all sorts of vehicles. I think HGVs probably being the biggest market, so also trains and buses, and I think some opportunity for cars, but a bit more limited compared with electric vehicles. Moving on, another key use of hydrogen I mentioned was flexible power generation. Just on this map, I'm just showing that the main combined cycle gas turbine plant that are either operating or under development in the northwest and North Wales. So you've got Rock Savage at Runcorn, ESB Carrington at Carrington, Carlton Power, which is a fully consented CCGT again just down the road at Carrington, and Connors Quay in North Wales. So large scale plant that can be switched over to operate on hydrogen as soon as it's available from HyNet. The technology is there at the moment with guarantees for those plants to use about up to 40% hydrogen, and the OEMs are sort of developing the turbine technology, etc., to be able for those plants to switch to 100% hydrogen in the late 2020s, assuming that that the fuel is available. So we're also, in terms of flexible hydrogen, aiming to deploy new smaller plant along the pipeline network in the next sort of 5 or 6 years. So we've got a number of sort of projects at fairly early stage in the sort of sub 50 megawatt scale that'll be able to support the electricity network and deliver some flexibility from hydrogen and low carbon flexibility to replace some of the natural gas peaking plant that are online at the present time. So on to sort of the main area that I focus on within my work. One of my main sort of day jobs is to lead our sort of engagement with industry and trying to make sure those on our network, as soon as we can get the pipeline to them, are ready to take hydrogen. So I've been running a set of industrial fuel switching demonstrations, which have been funded by BEIS. That's been fantastic sort of program of work and fantastic support from government. Government has been supporting that, as well as getting its business models in place. So it has had a well integrated sort of approach in that. We'd like them to be moving faster with the business models, but they've certainly been sort of supportive on all fronts. The objectives of the fuel switching programs, we want to enable not only the participating sites, but wider sites within the North West and North Wales, but also across the UK and globally, that evidence to enable them to switch to hydrogen as soon as it's available. The programmes of work are fully funded by government, and therefore there's quite, we have to share a lot of knowledge. There's a quid pro quo on that, share a lot of, or nearly all of the knowledge that's developed from that work, and there's quite strict IP sharing terms within the contracts. One other thing we've got to do is determine what the cost of switching is for relevant sites to hydrogen. Prove there's no negative impact on plant and equipment, and also that the sites can actually run on hydrogen whilst both conforming with all safety regulations and within complying with the requirements of their environmental permits and the emissions thresholds associated with those, particularly relating to NOx emissions, which are often perceived to be an issue with hydrogen combustion. So the first phase of the programme that we've run, we're just sort of in the final throes of writing up the public facing report on this programme. Was a set of demonstrations. So Progressive, we've been the main contractor to government on this. It's been a 5.3 million programme which we commenced in 2019. There have been some challenges associated with. I don't think I'd ever try and run physical demonstration programmes when kicking them off sort of 3 months before a pandemic hit globally. So not only did that affect the supply chain, but also being able to get on site for quite long periods of time. And some of our main partners stopped all procurement during the first phase of lockdown, which threw some real challenges into that. I think one of the other big challenges running demonstration projects at scale is, whilst we have big aspirations to produce significant volumes of hydrogen, there's quite a dearth of available what we call merchant hydrogen on the market that you can buy in today to support projects which have quite a high demand for hydrogen for a relatively short amount of time. The hydrogen industry at the moment that supply hydrogen for chemical processes mainly is used to very long-term contracts with not necessarily significant volumes. That's quite a change for them in that process. Our main hydrogen suppliers for this first programme was BOC, so they supplied both our demonstration project at Pilkington Glass, or NSG, so a direct firing application into a furnace, which I'll talk about again in a minute in a bit more detail. And then other sort of main demonstration project was at Unilever's Port Sunlight site, so hydrogen firing in an existing package boiler, 7 megawatt package boiler at that site. I should mention as well that the firing at Pilkington Glass is into an existing glass furnace. We also had another work package with Essar at Stanlow, whereby it wasn't a demonstration, but we undertook a feed study for a new 75 megawatt gas turbine hydrogen fired combined heat and power plant. So that piece of work was completed a year or so ago, that feed study, and that basically has enabled us to be in a position to go forth and get consent and take that project to an investment decision and switch Essar's existing CHP over to a new hydrogen-fired CHP with relevant guarantees from the OEMs, or the relevant OEM. So in terms of the NSG demonstration, so I'm conscious of time. I've gone well over time. I think I told Chris I'd talk for 25 minutes, so apologies. Hopefully people who still have time for questions. I'll romp through the last slides. With NSG, glass furnaces tend to be switched off only once every 15 years. So hydrogen is an ideal sort of drop-in fuel for natural gas. You don't need to turn the furnace off, unlike if you were trying to electrify that kind of infrastructure where you need an entirely new furnace. So you're using the existing furnace, and indeed at NSG we just needed to switch the burners out and adjust the controls. So relatively low capex form of switching, which would be the same if you were switching in perpetuity compared to a demonstration project. So that the hydrogen was supplied with tube trailers, so 3 tube trailers stacked up next to each other, switching those out as soon as they're finished at NSG. You see the picture at the bottom right, it's just some sheet glass coming off the end of the line. So what we were able to do at NSG was to demonstrate that we had effective heat transfer to the raw materials that go into making glass, that NOx production was within the capability of the existing abatement equipment to keep the plant within its environmental permitting thresholds. Like, another concern had been soda production within the furnace, and we demonstrated that could be done within existing operating experience, and that critically glass quality was not affected by the demonstration. So what we managed to do was show that we can decarbonise with hydrogen 60% of the energy use of that furnace, and that gives NSG the confidence to make an investment decision to have effectively agreed to a hydrogen pipeline connection to their site. So we've proven we can switch the melting end of the furnace. The rest of the furnace will continue to be fired by natural gas until we have hydrogen there in bulk from HyNet, and then incrementally they can decarbonise the refining end of the furnace with hydrogen as well. So that was a really successful demonstration that completed in August last year. Our other main demonstration at Unilever, we first of all ran a sort of validation, I guess, a test sort of project at Dunphy Combustion in Rochdale. Dunphy is the supplier of the existing burners at Unilever. That effectively gave confidence to Unilever to put hydrogen in its own boilers. So Dunphy played a critical role in that. Really sort of can-do organisation and a great partner to be involved in that process. But essentially at the Dunphy test, we were able to sort of show reliable and safe production at steam at the required temperatures and pressures. We were able to show the burner modulation ratio that Unilever needed. We were able to operate well within NOx limits, and I'll come back to that later, but well within the medium combustion plant directive limits. And we could produce a flue gas which has sufficient temperature to prevent significant condensation in the stack. So those sort of success criteria written into the contract with Unilever that we had to get past before we moved on. If I can just pause for a second, actually, I have this classic thing that my son has just started using his drum kit in the room above my my study. Just bear with me 2 secs. Sorry, guys.
No problem.
Otto, can you stop drumming, please? Can you stop Otto drumming, please? Sorry, guys.
No worries.
That's it. And I'll try to finish off quickly because I'm conscious I'm going well over time. So yeah, the Dunphy project was successful. We then were able to move on to the main demonstration at Port Sunlight. As I mentioned, was a 7 megawatt package boiler. You can see in the bottom right that a new burner was put into the existing boiler. That's the burner going in, as you can see in the bottom right. Again, BOC was the hydrogen supplier for this. We had two phases of pressure letdown from the tube trailers. You see the pressure letdown, main pressure letdown station in the centre there. It was at Unilever's sort of fairly iconic Port Sunlight site. And really, I guess the key thing, from the demonstration, we were able to verify all the work that was done at Dunphy, again, operate within NOx limits, and the performance of the boiler was able to verify. The key thing we learned, actually, that in terms of NOx performance, the demonstration at Dunphy went almost too well, down to boiler geometry. And we did have some sort of further challenges in getting NOx down to the limits we needed at Port Sunlight, but we were able to do that by adjusting the burners and flame within the boiler to get us below medium combustion plant limits. But there was some key, really good learning from that process that can then be rolled out to other industry sites that have maybe challenging boiler geometries. that enable them to operate on hydrogen via that process of amending the burners and flame controls. So that was some really useful sort of science went on as part of that process. And as I said, the reports on this work are going to be just being submitted to government for sharing publicly in the next couple of months. I promise I'm the last couple of slides now. We've just got funding. This is actually going public, officially public next week in terms of the detail. But we've got funding for 5 further fuel switching projects. Again, with Progressive as the lead bidder, working with PepsiCo, Kellogg's, Kraft Heinz, Novelis, and Essity. So 2 projects focusing on food processes. On Novelis in the aluminium sector, Kraft Heinz we're looking at a new gas engine CHP, and Essity in the paper sector. So I can't say too much about those projects, but until they're officially announced by government next week, or I'll be breaching my contract with government. But that should be the goal of doing this work, was really to focus on industrial processes which aren't yet proven on hydrogen, so we can again build that evidence base to enable not only these sites but other sites to be hydrogen ready as soon as possible. As mentioned, I've got MOUs in place with about 30 sites at the moment. MOU is about as far as we can go at the moment commercially until we actually get to financial close and we can supply, get to more formal detailed supply contracts once the phase 1 and 2 networks reach an investment decision. The other thing to mention with these, they're likely to be interruptible supply contracts, because it's certainly in the initial years we're going to have one site for hydrogen production in the initial years. It's going to have nowhere near the resilience of the existing gas network. So there will be interruptible supply contracts, but very importantly, I think I didn't mention this earlier, so it's important I do now. Whilst we will be putting new hydrogen connections and the new network in, all of the industrial sites will maintain their existing natural gas connection. So they will have the ability, and we're demonstrating through the demonstrations they will be able to switch back to natural gas at any point, or combinations of natural gas and hydrogen thereof. So that's a key part of the demonstration work that we're doing to give that resilience that obviously industry needs to operate. That's my last slide. Sorry to talk for so long, but thank you. I hope you're all still there and have found that interesting. But thanks very much. I'll stop sharing my screen now, but available for questions.
Thank you, Alan. That was brilliant. Clearly, you're enthusiastic about hydrogen, which is brilliant, and also you solve the same problems as a lot of parents out there trying to do. I think we should leave that in just for all other parents. So thank you for that. So I think we just have I've got some questions I received by email actually for people who couldn't join. So I'm just seeing there is some just popped in now. So a question here from Andrew Brown. Did you have to address any issues with with differences in flame temperature between hydrogen and natural gas, especially when dealing with potential customers that require defined temperatures for direct burn applications? Would there be any such issues with switching fuels?
Yeah, it's probably a question I would bring in my engineering lead to answer. But yeah, I mean, I think there obviously are different flame temperature issues and other flame issues around flame speed, flame length, etc. that we've had to deal with. I mentioned those around the boiler, and particularly relating to NOx. I think the question was more around direct firing than indirect, but I think that the general answer is yes. Yes, I hate sort of saying I'll come back to you later, but yeah, happy to go into more detail on that offline and connect you with my engineering lead around that particular issue.
Is that part of the reason for the 20% blending limit, that you don't have to overcome issues with
No, I mean, I think the 20% blending limit, it relates to, sort of more domestic environment, when not having to put in new boilers and things, rather than industry. So yeah, that's where that comes from.
Okay. One question I had was about storage and using hydrogen as a storage medium. I don't know if that's something you've got some thoughts on, or the project has looked at.
Yeah, I mean, certainly, we obviously need significant storage to operate the network as a system. So Innovin is leading that part of things. Actually, a slide I neglected to put in, which I usually do, is around the status of that infrastructure. So Innovin has consent at the moment for what's called the Kuiper gas storage project, which is a natural gas storage project. So 20 new natural gas storage caverns. So it didn't get to financial close on that infrastructure. So it got consent in 2017, I think. So rather than it would normally need a new development consent order for those caverns, what it's able to do is actually seek a variation in that consent for that to be switched to hydrogen storage. So there will be, we're aiming, I think, for 3 terawatt-hours of storage to be in play by the time the phase 2 network is operating. That'll be down just south of North, which is part of the Kuiper project. And that'll be, as I said, underground in salt caverns, to give us significant storage that the network needs. I think there will be, I guess, we're not looking at sort of any overground kind of sort of tank storage. That there may be a bit of that needed for the green infrastructure, but not as yet.
And is that storage for thermal use or for to re-electrify for electricity demand?
The storage, yeah, I mean, the storage will largely be the salt cavern storage will, I guess, for fluctuations in demand from the network, but also from flexible power generation. I showed some quite significant power generators on there, so that will seek to cope with those fluctuations. Yeah.
And obviously, it covers off some of the issues with batteries and degradation, and I guess the fairly short-term limited nature of the cycles. So that term demand, perhaps.
So this is been large scale. I don't think any battery gets near sort of 3 terawatt-hours of storage. So
no, that's pretty big. Yeah, there's a big tray of lithium, isn't it, when you get to that stage?
Yeah, I don't think our sort of round trip efficiency is from power to hydrogen back to power is anything like as good as the batteries, but it does give that on that large scale.
Yeah, I think you're right.
Terawatt scale.
Another question that's just come in on the chat from Brian Rose. He's asking what technology was used to mitigate the NOx emissions.
Yeah, I mean, we essentially with the boiler project was done via a low NOx burner, and some of the techniques I said, sort of adjustments to the flame, taking into consideration furnace geometry, etc., which proved fairly critical with Unilever. We did use flue gas recirculation at we didn't need it at Unilever. Well, as I said, the Dunphy trial went almost too well in that we got far below the sort of 200 milligram requirement of the MCPD. So we got very much below it when we tested using FGR at Dunphy. So when we came to the Unilever trial, we didn't believe we needed it, so we didn't put it in. In the end, we didn't need it, but we had to do a lot of tinkering, which was good from a science perspective. But I mean, the MCPD at the moment is at that 200 for other gases, which hydrogen's classed as. In the future, as with any, particularly if hydrogen becomes much more widespread, you can see the Environment Agency tightening that limit. So our advice to sites at the moment is that we're working with to be hydrogen ready is perhaps don't put an FGR because it's expensive and there's an energy penalty. Don't do that from the start, but actually leave space for those pipes within your engineering design, so that can be retrofitted in the future if needed.
Okay. So there's almost nothing that's unique to hydrogen for emission control compared to natural gas.
No, not really.
It's the same. That's good. It's the same techniques.
Yeah. Same.
Another one that came in to me earlier today was around. I think you touched upon this a little bit, so I'll probably adapt the question slightly. You mentioned there was going to be a gigawatt by 2030 of green hydrogen being
gigawatt of blue. I think I said, yeah.
Right, it was a gigawatt of blue.
Yeah.
So what's the proportions in terms of green blue then that you'd expect?
Difficult to fully estimate. I mean, yeah. So we our first train of blue will be about 350 megawatts. Second train 650. Very dependent on the what I call the phase 2 of cluster sequencing. So getting that funding through. I think we're pretty optimistic about the first train. We're not sure about whether we're going to get the 650 part of this round. You know, I think government, if it's to meet the ambition of the hydrogen strategy, which is now, you know, with the that since the energy, I think the hydrogen strategy was 5 gigawatts of production by 2030. The energy security strategy has doubled that target to 10 gigawatts by 2030. Government at the moment, unfortunately, you know, in the interactions with Treasury, I'm sure Bays would like to do more. The funding envelope that government has put out there is nowhere near matching their policy, you know, the narrative and the ambition of the politicians and what's been put out there. So we're pushing very hard, you know, for that to happen and for that envelope to be increased to enable us to deploy more. Green, our first project will be 20 megawatts. To deploy that by 2025. We're looking at several other projects of a lesser scale, actually, that will be co-located at industry sites. As far as we know, that's the biggest that have been planned in the northwest at the moment. I suspect as we get into the later 2020s that some more, you know, larger projects may come online. It's particularly if they, you know, they really depend on our network getting built, then they can supply into the network. If the network doesn't get built, I can't see them being successful, because, you know, not many industry sites will take, for example, 100 megawatts of hydrogen. So very network dependent.
Okay. And what's the price point between green and blue? You know, well, how does it compare to?
Sorry.
Well, how does the price point compare to producing hydrogen from green sources rather than blue?
Price point is still, I mean, obviously, you know, price of natural gas has gone up considerably. Well, it's actually gone down quite a lot since its peak in the UK sense, albeit obviously, you know, there's a global market and it depends upon how you look at it. We used to, you know, frequently before the spike in prices, you know, caused by, you know, what's going on in Ukraine, unfortunately, talk about being about a third of the price of electrolytic hydrogen. We still think blue is considerably cheaper than electrolytic because the price of electricity has gone up considerably as well, because of Ukraine. And a lot of the modelling that's done on green hydrogen, you know, people will believe that they can produce, you know, can source electricity at the cost price of offshore wind, you know, 3p a kilowatt hour. It's the opportunity cost of that which sets the price, and if others are willing to pay, you know, 10 pence a kilowatt hour, that's what the price will be if you're putting it into an electrolyzer. So there's all sorts of sort of, you know, nuances associated with that. But as I said, you know, without going to too much detail, you know, I think we're still some way below the price of green. But, you know, I think that the two are coming a bit closer together in recent months. Yeah,
okay, that's brilliant, thank you. I don't have any more questions that come in. I'm just looking at the chat. I don't think there's any more. Dan, have you anything else to add?
No, not from me, but yeah, well, no, thank you, Adam. It's been really good. Thank you very much.
Pleasure. Okay. Pleasure.
Yeah, so thank you. Yeah, I think it's just 7:05, so I also heard your tea was ready downstairs. So
I just hear that as well.
I need to go for that before it's cold. My mind will be the same. So I just want to thank you very much for your presentation. We'll get the link sent out in the next couple of days, and we'll look forward to seeing what next steps in the project there are, and maybe we'll get you on a little bit future to tell us what's next.
Great stuff. Well, thanks for inviting me, and thanks for listening all, and have a good evening.
Thank you. Cheers.
Cheers, guys.
Thanks very much.
Bye.
Thanks, Adam.